In this next part, we have to take now these two different equations we have for the slope for each segment, and we got to deal with them somehow. Maybe we can deal with C1 and C2 even though we don't have boundary conditions that relate to that. We do have a continuity condition at the midpoint that tells us some information here. That is, the slope at either side is equal to each other. Now note, remember that the EI is constant here, so we can multiply both of those by EI, and it actually makes things a little bit easier when we do that. Put the minus sign in the wrong place there, and EI theta to the right now at L over 2 has to be equal to each other. So on the left hand side we have then P over 4 times L over 2 squared plus C1, and that would be all times EI. And on the other side we'd have EI times minus P over 4 times our L over 2 squared plus and PL over 2 times L over 2 plus C2. Right? Now this is tough stuff to get done right. Right? The EI's cancel out, they're the same, so that's nice, right? And so we come along, and this is going to be PL squared over 16 plus C1. This is going to be minus PL squared over 4 times 1 over 2 squared, so that's over 16 plus PL squared over 4 plus C2. So C1, then we take that to the other side. That'll be a net of minus 1/8 plus the 1/4. We'll end up with PL squared over 8 plus C2. That will be a useful equation. It relates what those two constants are for us, and we still not used our original boundary conditions, which we don't know anything yet. Anyways.